Bismillah ar-Rahman ar-Rahim. And I will go back to this question and another one, and then I will continue. This is just a continuation of section 3.1. And this section, I said it's 3.3. Yes, it is. It is quotient. I mean, I need the quotient rule. But however, you can find the derivative using the formula. This is another way to force you to find the derivative. When he says find the slope of the tangent line to this curve at this point, it means they want f prime at 1. And f prime at 1, regardless if I don't know the formula, I don't know how to find the derivative using the rules, I can do it using the limit. If I say both limits are okay, this may assume x goes to 1, f of x minus f of 1 over x minus 1. Just do the calculations, and this is just a limit, so you can find it. So that will be 3x plus 1 over x plus 3 minus what? What is f of 1? F of 1, 1. He gave me it's 1. So this is 1 over x minus 1. Then just a limit. Do its calculation, and that's it. You get the answer. That will be 3x plus 1 minus x minus 3 over x plus 3 times x minus 1. And that is limit is goes to 1. What is this? 3x minus x, 2x minus 2 over x plus 3 times x minus 1. What is this? This is 2 times x minus 1. This is cancelled. So I have 2 over 4, which is half. So this is the answer. But I meant here it's to find it using the rules. I need the quotient rule, and it's functional function. So I need the quotient rule. Let me go to the last question we did. We did all of these problems. This one, and I'll try to do it again. It says what? I have f of x, 3x squared plus a. If x is less than or equal to 0, bx minus c, if x is greater than 0. Right. Yeah. They said it's differentiable everywhere. Differentiable everywhere. Find a plus b equals what? That was the question. Okay. Just to be sure that the message is received, when they say differentiable everywhere, that means two things for me. It means it's continuous everywhere. Two, differentiable everywhere. So this will give me another statement, which is continuous. If it is differentiable, it's continuous. Continuous, I know how to deal with it. This function, these two functions are two smooth functions, so I need to check at 0. So it means limit is goes to 0 from right equals limit is goes to 0 from left equal if at 0. Substitute from right, I am here, so it will be b times 0 minus c equals left, I am here, that will be 3, 0 squared plus a. At 0, it's a. So that means what? Minus c is equal to a. So a equal minus c. This is part 1. Now, to check differentiability, you need to check limit. You need to check f prime from left at 0. And we're sure we are concerned about 0. Huh? Is equal to f prime right at 0. So that means f is differentiable at 0. That's what I need to check. You can do it two ways. You can find this using the limit and find this using the limit, and you equate them. This is one way to do it. And for sure you will get the answer. Another way, let me do it this way. F prime from left means what? Limit. Let me do it quickly. H goes to 0 from left. F of 0 plus h minus f of 0 over h. That means what? 0. This h from left, I am here. Substitute. You get the limit. H goes to 0 from left. Of what? I'm here substituting here. That will be 3h squared plus a. F of 0 is what? A over h. So the answer here is 3. 0. It's not 3. The answer here is what? This equal limit h goes to 0 from left. This is cancelled. I have 3h squared over h, which is just 0. Okay, this is one side. The other side, for this right, h check limit, h goes to 0 from right, f of 0 plus h minus f of 0 over h. From right means this one, I am here. So just substitute. That will be limit h goes to 0 from right, bh minus c. What is f at 0? F at 0, we say it's a over h. But I know a equal minus c. A equal minus c. So this is will be limit h goes to 0 from right, bh minus c. If a equal minus c, this is plus c over h. This is cancelled. So the value will be b. So for sure, from these two, I'm getting b equals 0. So b equals 0, a equal minus c. So that implies a plus b equal minus c. This is one way to do it. The second way to do it is how to find the derivative from a piecewise function. How to find the derivative of this right away. This is the catch. If this function is continuous, and we agree it's continuous, because he told me differential, so it's continuous everywhere. So just you find the derivative of each part. First, I need to check the function is continuous. And it is. Because he said differentiable, so it's continuous. First, I need to find the derivative of each part. What's the derivative of the numerator? I'm getting 6x. Where x less than 0. Okay, I did not put the equality. What's the derivative in this one? Minus c. Where x less than 0. Since he said it's differentiable, so it means the equality is here. Or there. It's okay. That's an equality. So that means at 0, I have 6 times 0 equal minus c is equal to b. Sorry. This is b. Is equal to b. This is something else. So b equals 0, which is the same answer. And by the way, this represents f prime from left at 0, which is 0. And this one represents f prime from right at 0, which is b. So these should be equal. So this is what we gave me 6 times 0, or 0 is equal to b. I wish it's clear. Which of the following functions has a vertical tangent at 0? Remember, vertical tangent, two things. F is continuous, at 0. And what is the vertical tangent, by the way? It means x equals 0 to the limit, this goes to 0, of f prime is equal plus infinity. They put the absolute value just to be, yeah, so they need to write plus or minus infinity. Now check them one by one. Is this function continuous at 0? No, not continuous at 0. Not defined at 0, so not continuous. This one, same thing, not continuous at 0, not defined at 0, so this is out. Let me come here. This one continuous at 0, yes. This is not continuous at 0. This one continuous at 0, it's continuous at 0. What is f prime? But f prime at x equal to what? 4 over 3, x to the power 1 over 3. So the limit of f prime as it goes to 0, it will be what? 4 over 3 times 0, which is 0. So this condition not satisfied. So this is out. We'll come to this one. Continuous at 0? Yes, continuous at x equals 0. But not differentiable. Not x equals 0. Not differentiable, not because going to infinity. Not differentiable because limit of the derivative f prime left will be different than f prime right. And here f prime right at 0 is 1, and f prime left at 0 equal minus 1. So they are not the same. So this condition not satisfied. So this is out of the picture. Now it comes to this one. F is continuous at 0. Yes, defined, nothing to worry about. So this is okay. Second, what is f prime? It's 2 over 3, x to the power minus 1 over 3. Which is, in other words, 2 over 3, x to the power 1 over 3. There's 1. 2, the limit, f prime, as x goes to 0, will be 1. The limit of this function, 2 over 3, x to the power 1 over 3, as it goes to 0. Which is for sure, since I put the absolute value, goes to plus infinity. So these two conditions satisfy. So this is correct. X equals 0 is a vertical asymptote. Is a vertical tangent, I mean. Sorry about that. He gave me a function with some conditions. I told which the following graphs could be the graph of this function. Solve this question, you need to do it by deletion, by canceling the wrong ones. So I do it first. He says f of 0 equal 1. Forget about the derivative, then I'll come to the derivative. F of 0 equal 1. Here f of 0 equal to 1. Here f of 0 equal 1. 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 I'm getting nothing out of it. F of 2 equals 0. F of 2, 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 0. I'm getting nothing out of it. Okay. Let me back to f prime. So I have f prime at 2 equals 0. F prime at 2 equals 0. So let me check them. Here, the slope of the tangent line is 0, so it's f prime at 2 equals 0. Here, the slope of the tangent line is 0, so it's f prime at equals 0. Here, the same thing. Here, the same thing. Here, f prime at 2, the function is not differentiable at 2. So this will be out. This is not correct. C is not correct. That give me C cancelled. Okay, let me go f prime at 0 equal 1. The most important is not 1, it's positive. F prime at 0, positive. That means the slope of the tangent line is positive. Okay, let us check at 0. This is at 0. The slope of the tangent line will be something like this, which is negative. We know this is negative, so this is out. So A out. B, the slope is, tangent line is like this, which is positive. I'm getting nothing out of this. Okay, here at 1, I'm getting what? Positive slope. That's okay. Here at 0, the function is not different. So this is out. So E out. Now the remaining is what? B and D. These are the two remaining. I'll take the last one. F prime at 1 is negative. So it means the slope of the tangent line at x equal 1 should be negative. At 1 it's not differentiable. This is not differentiable. F is not differentiable at 1. Minus, no. We're talking about what? Yes. It's out 1. This is, yeah, this is 1. Yeah. F is not differentiable at x equal 1. So this is out. Here at 1, here is 1. This is not 1. This is half. Huh? So this is the slope, which is what? Negative. So this satisfies all the three conditions. So this is the correct answer. And this one cancelled what? B. So A out, B out, C out, D out, means D is the correct answer. I wish it's clear. Let F be a function. We did something similar. If F is differentiable, find for A plus 5B. Find A and B. That's mainly the things. As we said before, it has another condition embedded. F is continuous. X equal minus 2. That means what? Limit as this goes to minus 2 from right equal limit as this goes to minus 2 from left equal F at minus 2. Minus 2 from right, I am here. Just substitute. You'll get what? 4 minus 2A plus 3B equals minus 2 from left. I am here. That will be what? Minus 4 plus B. F of minus 2 will give me nothing. Minus 4 plus B. Nothing is there. So just, rearrange it. It will be 2A. Take this to the other side. Minus 2B. Take 4 to the other side. Or take is equal to 8. Correct? Yeah. I took the 2A. I took the B. I took the minus 1. Minus 4 here. This one there. So 2A minus 2B equal 8. So A minus B equal 4. This is the first equation. From where I get the second equation? From this. If it's differentiable, that means F prime left at minus 2 is the same as F prime plus at minus 2. You can do it using the definition, limit something, or you can do it right away since I can do the derivative. I say F prime. Since the function is continuous, he told me the function is continuous at this point. And these functions are always continuous, so nothing to worry about. So this is 2. If x less than minus 2, this is 2. Just I will do the derivative of each function alone. And this is 2x minus a if x greater than minus 2. And I will put the equality. Why I put the equality? Because he told me it's differentiable. at x equal -2. خلاص. And this will be f prime left at -2. And this will be f prime right at -2. So f prime left at -2, substitute -2, 2. F prime left at right at -2, substituted 2, you get what? -4 minus a. These two should be equal to each other. You can find them using the limit, using the limit definition from right, from left, or you can find them right away. That will give me what? 2 equal -4 minus a. So it means a is equal to what? Yeah, a is equal -6. Correct? Did I do any mistakes? This is 2. This is 2x minus a. -2, give me -4 minus a. -4 minus a is equal to 2. So a equal -6. There's something wrong somewhere. Let me check the calculations. -2. Yeah. This is -4 plus b. This is 4 minus 2a plus 3b equal -4 plus b. -4 plus b at -2. Then I have what? Take everything to this side. I have 2a minus 2b. Yeah, is equal to 8. So a minus b is equal to 4. Okay, find the derivative of this. I'm getting 2. Find the derivative of this. I'm getting 2x. This is plus a. Sorry for that. This is plus a, not minus a. This is plus a. So this is plus a. This is plus a. So a will be what? A will be 6. A will be 6. If a is equal to 6, that means what? 6 minus b is equal to 4. So it means minus b equals -2. So b equal to. So b equal to and a equals 6. So it will be 4a plus 5b. It will be 4 times 6 plus 5 times 2, which is 24 plus 10, which is 34, which is this one. So the mistake is plus or minus. Yeah, this is plus. The height in feet of a ball thrown in the air after 30 seconds is given by this. This is the formula. Find the average velocity of the ball in this interval. How to find the V average? It will be, call this F at T. It will be F at 2 minus F at 1 over 2 minus 1. Just substitute, nothing is there. F at 2, yeah, it will be 80 minus 16 times 4 minus F at 1. I'm trying to be careful in the calculation. 40 minus 16 over 1. And that will be what? Yeah, 80 minus 64 minus what is this? 24. Yeah, 24. Which is 80 minus 88, which is -8, which is this answer. Calculation. Now he's telling us this is equal to f prime at 2. f prime of a function. So I want to represent this in terms of the derivative. And actually saying this is f prime at a, find f and find a. Notice this, f prime at a is the limit. It goes to 0, f of a plus h minus f of a. So how to read from the limit, how to read the derivative. This 64, if you notice it, it's 2 to the power 6. So my a is 2, very clear. So this is 2, this is 2. And everything ready. This is a plus h to the power 6. So what will be my function? X to the power 6. This is my function. You can check, find this using the definition. F prime at 2 is the limit. H goes to 0. F of 2 plus h minus f of 2 over h. I'm trying to be sure I'm getting the same thing. That will be limit. H goes to 0. 2 plus h. The function is x to the power 6. So take this to the power 6 minus 2 to the power 6 over h. What is 2 to the power 6? Is 64. Which is the same one. So this is correct. Which is this one? Suppose f satisfies this relation. A relation. Okay. For all real numbers x and y. Suppose also this limit is equal to 1. Find f prime at x. I say f prime at x will be the limit. H goes to 0. F at x plus h minus f of x over h. What I will do, since this is true for any x and y, so I'll make this x plus h. And I just substitute. That's it. You'll get the answer. Limit is goes to 0. What is f of x plus h? Substitute there. So instead of x, x will be the same. Y will make it h. So that will be f of x. F of y will make it f of h plus x squared h plus h plus x h squared. Instead of y, I make it h minus f of x over h. I just do substitution. Now this is cancelled. Now check what is the remaining. I have f of h over h, which is this one. Because of that, I took it away. This is f of h over h, where h goes to 0, which is the same. Plus, here I have what? I have these two. I can take h common factor, x squared plus xh over h. So this will be the limit as it goes to 0. F of h over h. I know this limit exists. Plus limit, he told me, exists is equal to 1. H goes to 0. H x squared plus xh over h. This is cancelled. This x squared will not be affected by the h, so it will be remain the same. This one will go to 0 since h going to 0. So that will be 1 plus x squared. So this is the answer. Consider this function. Which of the following is true? Which of the following is true? The domain of f prime is this. The domain of f prime is this. The domain of the double prime, f triple prime. If it's discontinuous at 0, wrong. This is very clear wrong. Don't know if it's continuous at 0. Check. Substitute 0, 0. So f is continuous at 0. F is continuous at 0. Actually, it's continuous everywhere. How to find f prime? F prime, as we did before, just do the derivative to x. If x greater than 0, 3x squared. If x is less than 0. Look, I did not put the equality. Now I check. As x equals 0, that will be this. As I said before, this represents f from the right, and this represents f from the left. At 0, they are equal to each other. This is 0, this is 0. So I will put the equality. F prime is differentiable. It means f is differentiable at x equals 0, since they are equal at 0. You notice f prime plus at 0 equals 0, and it's equal f prime minus at 0. So it means f is differentiable at x equals 0. So what's the domain of f prime? By the way, what's the domain of f? All real numbers. Everything is defined everywhere, also at 0. What's the domain of f prime? All real numbers too, since the function is differentiable everywhere. Now we'll come to f double prime. What we will have? We'll do the same thing. This is 2. If x greater than 0, we have 6x. If x is less than 0. Can I put the equality? No, we cannot do this. Why? Because f double prime plus at 0 is equal to 2. But f double prime minus at 0 is equal to what? 0. So f double prime at 0 does not exist. So what's the domain of f double prime? All real numbers except 0. The function is not the function is not second differentiable at x equals 0. So when he said now the domain of f prime is this is wrong. The domain of f double prime is this is wrong. So we find the domain of f double prime is all real numbers except 0. Now when it comes to this one, third derivative, which is first you check f double prime, is it continuous? No, because you need to find the derivative of f double prime. It's not continuous, so you cannot continue. So this is also wrong. I mean, at 0, if the f triple prime is not defined or does not exist. So the answer is this one. I hope it's clear. This function, which is we said it millions of times, x to the power 1/3. What will be y prime? This is the vertical tangent is x equals 0. Why? Because x equals 0 is a vertical tangent. Why is that? He's talking about the vertical tangent. Horizontal tangent, no. Vertical asymptote, horizontal asymptote. Removal discontinue at x equals 0. No, it's continuous at x equals 0. It has a horizontal asymptote. No horizontal asymptote. As it goes to infinity, x goes to minus infinity. I'm getting nothing. Vertical asymptote, no, actually it's defined at x equals 0. So no vertical, it will not go to infinity or minus infinity. Horizontal tangent, what's the meaning of horizontal tangent? You need to find, just let me put the condition. F is continuous, then I will check them. At x equals 0, the limit as it goes to 0 of f prime at x equal plus infinity. Horizontal tangent means what? Means y prime equals 0. So what will be y prime? 1/3, x is minus 2/3, 1/3, x to the power 2/3. So for sure, it's impossible. Nothing. If you make this y prime equals 0, you are getting nothing. 0 equal 1/3, x to the power 2/3. That implies 0 equal 1, which is wrong. So I have no point here. So there is no horizontal tangent. I have vertical tangent? Yes. Why? Look at these conditions. First, f is continuous at x equals 0. Yeah, very clear. Nothing to worry about. Everything is defined. This is cube root, so it accepts plus or minus. Second, this is the derivative. What is the limit? As this goes to 0 of this expression. 1/3, x to the power 2/3. Very clear, it's plus infinity. So these two conditions satisfied. So I have x equals 0 is a vertical tangent, which is, oops. This one. So this is the correct one. Now the equation of the tangent line to this curve at the point where x equal 2 is this. He gave me the tangent line, equation of the tangent line. This is the equation of the tangent line at x equal 2. So this is my point of tangency. What he want f at 2 and f prime at 2. Okay. I have a curve. I don't know what is the curve. This is a curve. And I know at 2, this is the tangent line. This is my tangent line. Y equal 4x minus 5. Who cares? It's here, it's up, it's down. Who cares? Forget the x-axis, y-axis, to be in the same side. So at the point 2. This is the point of tangency. As I said, this is a very important point. Why? At this point, the function, the curve, I mean, and the line, they agreed. F at 2 is the same as y at 2. The curve and the line agreed at 2. Not only that, the slope of the tangent line to f, let's call it f, at x equal 2 is f prime at 2. Plus, I have these two information. F of 2, call it 2. F of 2 is equal y at 2. It's equal to they agreed at the point 2. And the slope of the line tangent to this is f prime at 2. This is what I need. F of 2 equal y at 2, which is, I can substitute the 2 there. It will be 4 times 2 minus 5, which is 3. This is f of 2. How to find f prime at 2? What is the slope of this function? Slope, we call it m usually. It's only 4. Is equal to 4. So f prime at 2 will be the slope of the tangent line, which is 4, since this is the tangent line. So it will be f at 2 plus f prime at 2. It will be 3 plus 4, which is 7. Consider this function. Find all values of b, which make the function differentiable at x equal 1. Okay. First, it should be what? Continuous. I'm not sure if the question is correct or not. Okay, let me check. At x equal 1, it should be continuous. F is continuous at x equal 1. Check. That means 2 minus b is equal to 1. Limit from left equal limit from right. That means b should be equal to, yeah, it's correct. B equals, so let me do it in details. Limit is goes to 1 from right, equal limit is goes to 1 from left, equals f at 1. From right, I am here, that will be 1. From left, I am there, that's 2 minus b. So it means b equal to minus 1, which is 1. This is b. So my function is 2x minus 1, where x is less than 1, x squared, where x is less than or equal to 1. So this function, for sure, is continuous at x equal 1. I don't need only continuity, I need differentiability. I don't have variables, I don't have constant here. So just, I mean, I don't have unknowns. So I can check differentiability, check f prime will be what? 2. As I said, I will make it without, and this is 2x without equality. And this represent f prime from left at 1. This is what I care about, because the rest are okay at 1. So f prime from left is equal to 2. F prime from right, 2 times 1, which is 2. So that means f is differentiable at x equal 1. So I will put the equality. I'll put it here or there, it's okay, since they are equal. So yes, the function is differentiable at x equal 1, if b equal 1. If b equal 1. So that the function is left-hand differentiable at x equal 1. This is a little bit tricky. Left-hand differentiable at x equal 1. I want to show you left-hand differentiable. It doesn't say it's differentiable. It's not differentiable. Why it's not differentiable at 1? Because you notice limit x goes to 1 from right equals what? 1. Limit x goes to 1 from left is equal to what? 2. So f is not continuous at x equal 1. So for sure, f is not differentiable at x equal 1. Okay. For sure, f is not differentiable at x equal 1. Okay. But I want to show it's left-hand differentiable. What's the meaning of that? It means if I do f prime from left at 1, this should be exist as a limit. So how to do this? I need to do it. The only way, I cannot do it by finding the derivatives. The only way is through the definition. So I'll check f prime left at 1. That will be limit. H goes to 0 from left. F of 1 plus h minus f of 1 over h. Check this limit. See what will happen. H goes to 0 from left. It means I am less than 1. I'm here. So just substitute limit. H goes to 0 from left. 1 plus h plus 1. F of 1 is what? Substitute f of 1. Very clear. F of 1 is 2. Minus 2 over h. It will be what? 2 minus 2, 0, h over h. So the limit exists. So f is left-hand differentiable at x equal 1. F is left-hand differentiable at x equal 1. Just this is the end of this section. Now we solved the problem. But is it right-hand differentiable? How to check? Let me check. F prime from right at 1. That will be limit. It goes to 0 from right. F of 1 plus h minus f of 1 over h. That will be what? Limit is goes to 0 from right. 1 plus h. I am here. That will be 1 over h minus 1 all over h. Okay. That will be what? Limit h goes to 0 from right. 1 minus h over 1 minus h over h times h. So it's 1 minus h over h squared. Oh, that's the limit, huh? I'm still doing the limit. Is it correct? 1 over h minus 1 over h, 1 minus h over h squared. So I need to do the limit. H goes to 0 from right. And that gave me what? 1 minus h over h squared. Which is, now this is what? This is plus infinity. Am I correct? This is non-zero over 0. So this is positive, this is positive, so I'm getting plus infinity. So f is not right-hand differentiable. Not x equal. Where did they go? Oh. Yeah. I hope it's clear. These some of the problems. How you can decide. Actually, I got it from the Stewart book. How to can decide the function is not differentiable. Where the function is not differentiable. Here in 41. This is not differentiable. Also at 0. So I have x, this is what? Minus 1, minus 2, minus 3. X equal minus 4 and x equals 0. Minus 4y, corner or sharp term. Corner. X equals 0, not continuous. Which is, this is the answer. I put the answers also here. If it's not differentiable, because the graph has a corner, x equals 0, because there is a discontinuity there. Okay. Now 42. Where is I have discontinuity? Minus 1 and 2. Which is very clear. Minus 2, minus 1. This is not continuous. And 2, we have corner. Now 43. Where we have differential, where we have problems, we have problems here. And we have problem here. So I have x equal 1 and x equal 5. X equal 1, I have what? Corner or sharp turn. Corner. Here I have what? Vertical tangent I have here. So I have vertical tangent at x equal 5. X equal 1. Is it not continuous? Yeah, this is going to infinity. Sorry, this is, let me check. Is it sharp turn? No, yeah. This is not corner. He meant infinity. It's not clear. I was thinking it's connected. It's not connected. So this is going to infinity. So not defined. So not continuous. What x equal? At x equal 5, I have a sharp vertical tangent. Vertical tangent here. Okay. Here, minus 2, I have a problem. I have sharp turn. Then it's turn. This one continuity in the 1. And here I have the same thing, sharp turn. So 44, I have at x equal -2 and x equal 3, I have corner or sharp turn, and x equal 1, I have not continuous. Not continuous, yes. Okay, this is the answers. Find an equation of tangent line to this curve, which is just, I need what? I need to find the slope, which is f prime at 2. F at 2 is already given. So we can find, we can solve it. How to find f prime at 2? Yeah, let me do it using the formula. This is x plus 2 to the power half. Since this is linear, coefficient of x is 1, I can use the formula. It will be half x plus 2 to the power minus half. That implies f prime at 2 will be what? Half times 2 plus 2, 4 times half. Under the square root of 4 in the denominator. That will be 1/4. So the equation will be y minus f of 2 equal f prime at 2 times x minus 2. So y minus half f prime at 2, which is 1/4, x minus 2. I multiply everything by 4, so that will be 4y minus 2 equal x minus 2. So I have 4y minus x equals 0. That's my equation. Okay. Notice this point satisfying the equation. Huh? Just checking point. These are the questions of the last year exams. This is in the first term. Find the slope of the tangent line to the graph at this point. What they want? F prime at pi/4. This is what they want. And using what? Using the definition. خلاص. So this will be limit. X goes to pi/4. F of x minus f of pi/4 over x minus pi/4. Just plug the numbers. X goes to pi/4. F of x is what? Sine square x. You give it to me. F of pi/4 will be sine pi/4 squared, which is square root 2/2 square, which is half, minus half over x minus pi/4, which is this one. The number of points on the graph of this, you want the number of points on the graph of this, having a tangent line parallel to this line. There is a curve, x cubed, who cares? There is a tangent line. You have curve like this, and they have a tangent line at a point. We don't know how many points we have, how something like that will happen, where the tangent line is parallel to another line, to this line. This is called it L1. So I can rewrite it. So I have y equal 3x minus 2. What's important? What is the slope of L1? Will be 3, which is this one. This is the slope of L1. Okay. I get the slope of L1. And what is the slope of the tangent line? M tangent, this line. What is the slope of that? It will be the same as ML1, which is 3, since they said it's parallel to each other. So I get now the slope of the tangent line. I get the slope of the tangent line. Okay. Now I want to relate it to the function. We know that the slope, to find this point of tangency, is asking about the point of tangency. So the slope of the tangent line to f at x equal a, this point, is f prime at a. Can I find f prime? Yes. F prime is what? 3x squared. So the slope of the tangent line of this is what? I got the slope is 3. So this is 3 equal what? F prime at A, which is 3A squared. So that means 3A squared equal 3. So that means A squared equal 1. So that means A equal plus or minus 1. So how many points we have? 2. Where the point have 1, substitute 1 and 5, and minus 1, substitute, and 3. These are the points. He doesn't want you to find the points, just how many are there. The value of K says that this line is tangent to this. But he put the K here. He wants you to find the K. By the way, this is from the book. The same idea. You have a curve. I know how to graph this. I know it's positive or negative, but it seems to be positive from the values. Who cares? This is I have a parabola. And there is a tangent line. I want you to find the K. The most important, this point of tangency. What is the relation between them? The slope of the tangent line to F at x equal A is F prime at A. That's the relation. That's the relation. Can I find the slope of this line? The slope of the tangent? Yes, it's only 4. It's ready. Is equal 4. But also, I can find it using the derivative. F prime at x equal what? Equal to kx. These two should be, that should be equal F prime at A. Assume this point A at x equal A. I just put it, huh? That should be equal to Ka. Two variables now. Okay. Make the problem worse. I put another variable. So that means Ka equal to, this is what I get. I need to find A. How to find A? Okay. I know that this A satisfies both the line and the equation and the curve. And F at A equal Y at A. No, so I'm getting another equation now. F at A means what? K A square equals, substitute here, 4A minus 3. So I have now two equations, two unknowns. That's it. This is what I'm looking for. So I have A equal K over 2. We'll make it worse like this. Huh? I have K equal 2 over A, or A equal 2 over K. Or I do it through K. No problem. You can do it this way or that way. Since I'm looking for K, I want to put everything in terms of K. Plug it there. You get what? K 2 over K square equal 4 2 over K minus 3. So this is what? 4 over K equal 8 over K minus 3. So we have what? 3 equal 4 over K. So 3K equal 4. So K equal 4 over 3, which is this one. I wish it's clear. One statement is true about this function and about this function. By the way, you can graph those two functions. For example, this one is what? This is sine. This way, that way. This is 9x. How to graph absolute value of sine x? Just this negative part, you will make it positive. So it will be the same. But here, I'll do what? Something like this. And then continue like this. So this function not differentiable. Not differentiable at these points, which is x equal n pi, where n is an integer. In other words, the problem if the things inside the absolute value is 0, if sine x equals 0, which is x equal n pi, the same thing. How to graph this function? Sine absolute value of x. You can think of it as what? Sine x, if x is positive. Sine minus x, if x is negative. You can put the equality here or there, no problem. Which is, in other words, it's sine x, if x is positive, minus sine x, if x is negative. If you want to graph it, I can also show you this is not differentiable at 0. This is sine x, the regular sine x. This one will be minus sine x. So instead of going like this, it will be multiplied by reversed. So at 0, I have a problem. F is not differentiable at 0. I mean, this function, call it f or g. They call it g, so g. Also, I can check it using the things we did before. What is f prime? This one not easy to rewrite it, but this one will be what? What is f prime? It will be cosine x if x is positive, minus cosine x if x is negative. What will happen at 0? Cosine 0 is 1. Minus cosine 0 is minus 1. So there is no equality. So f is not differentiable. Not f. At x equals 0. I mean g. G. This is g. G. It says the range of f means 0 to infinity. No. The range of this function, 0 included. So this is wrong. The domain of f prime, all this, where n is positive integer. No. Where n is any integer. So this is wrong. The domain of f of x from 0 to infinity. No. Domain of f and domain of g or real numbers. Huh? There's no restriction of this. So this is wrong. The domain of g from 0 to infinity. No. Domain of g is everywhere. Huh? It can accept the range. I mean, the range. The range of g, it can be negative part. So this is wrong. And this is what we did. All real numbers except at 0 is not differentiable. So this is the correct one. I wish this is very clear. With this f, I think I will do until the exercises, then I will stop. If x equal this, you want me to find this expression or the derivative. If you know how to find the derivative, you can do it, or you can do it the wrong way. That will be what? Limit it goes to 0. 1, since I need the chair rule, huh? Coefficient of x is not 1. 1 over square root 2 x plus h. Wait a minute, let me be careful in rewriting it. This is what? F of x plus h square root. Why I'm going to take 1 over, I don't know. 2 x plus h minus 4. This is f of x plus h minus f of x square root of 2x minus 4 all over h. So this is simplified square root 2x plus h minus 4 minus the square root 2x plus 4. This is just a square root, nothing is there. This is cancelled over h. So how to do this limit? I'm making it longer. 2x plus 2h minus square root 2h over h. I just rationalize it. You get the answer. That will be what? Limit. It goes to 0. 2x plus 2h minus 2x over h. 2x plus 2h plus square root 2x. Cancelled, cancelled. Then h also cancelled. You get what? 2 over. As it goes to 0, this goes to 0. 2 square root 2x. I'm getting 1 over square root 2x, which is this one. If the line is tangent to the graph of this, find k. Like what we did here. This question is the same. Exactly the same. So let me do it quickly. What we have f prime is minus 2x. So I have a problem. Doing like this is a problem. And then I have a tangent line. Who cares? Where is it? This is tangent line. I have this point A. This is the most important. I have the slope of this. M tangent is equal to minus 4. And I know at A, at x equal A, M tangent is equal f prime at A. So that implies, oh, this will be easier. I can find A quickly. That's minus 4 equal minus 2A. So A equal what? 2. You get an A. If you get the A, you can find yeah, this is the then what? Then at A, yeah. What will be Y? The Y at A equal F at A. Substitute A there, but this is now easier, huh? Before I need to solve an equation. Here, خلاص, it's ready. I get an A. Since when I did the derivative, I canceled the K. So this will be minus 8 plus 1. And this one will be K minus A squared. So I have what? Minus 7. Yeah, K, not minus A squared. A, I know it. It's 4. A is 2. So A squared, which is 4. Minus 7 equal K minus 4. So K equal what? Minus 3. And this is my answer. If this is f of x, find f prime at 0. How to find f prime at 0? Limit. H goes to 0. F of 0 plus h minus f of 0 over h. Since this is, I'm talking about x greater than 0, x, this one it has x greater than 0, x less than 0. So no need to check left and right. It will be the same. So I have h squared sine 1 over h. F of 0 is 0 over h. By the way, this is exactly from the book. Cancelled with the square. So I have limit h sine 1 over h. I know it's 0 by squeezing theorem, but you need to do some calculation, which is equal to 0. If the tangent line to this function at the point this passes through this, find g4 plus g prime at 4. I know that the tangent line to the graph at the point this, at the point this. So there is a function, and there is a tangent line at the point 4 and 5. This is the point 4 and 5. Passes through the point 7 and 0. Yeah, you can reverse it, no problem, huh? Consider this 7, it should be the other way. Let me, yeah, it should be something like this. This is 4 and 5. This is the tangent line. So this is 7 and 0. 7, this is this point somewhere, 7 and 0. This is what they mean. Tangent line to the graph of this, and the point passes through this. So this is the point of tangency. خلاص. Then G at 4 is what? Is 5. Since this is the point of tangency, which is both in the curve and in the line. What about G prime at 4? Is the slope of the tangent line. This is the definition. But this is yeah. I have 2 points. We can find the slope. If I have 2 points, that will be what? 0 minus 5 over 7 minus 4, which is minus 5 over 3. Just the slope, huh? Delta y over delta x. Now G4 is 5. This is minus 5 over 3. 5 is what? 5 is 15 over 3. So that will be 10 over 3, which is this one. Yeah, I think I'll stop here. Now I reach the exercises for section 3.1. Thank you.